Today we'll be working with the Godot engine and doing some exploration relating to the Open Learning Quest. Open Learning Quest aims to be an educational game where players are faced with challenges that need to be solved using knowledge of science and math. We don't know much more about the game right now. It's really just an idea, but the main idea is it's not going to be like flashcards or something like that. It's going to be an actual game, a story-driven game. So as such, we would like to explore how to create more point-and-click adventure type stories using Godot. So I'd like to start out today's session with the trying out the Escoria game template. This is the version 4 alpha. I think it's preparing for Godot 4 release, and they're getting ahead of the curve there. It's labeled as alpha, so we may have some problems, encounter some problems, but let's give it a try. And we will go ahead and whoops. Let's put this in. We'll just put it under the second hard drive. Games, Godot. Squirrel game demo. Install and edit. I don't want to like invent the wheel here. What we want to do is focus on making the things that are unique to our game and build on as many existing game mechanics as possible. Hence, using the Godot game engine, as well as trying to find some recipes or a framework for making these adventure games. All right. So that was a no-go from the start. Maybe there's a tutorial for it. Well, let's see. Let's try loading this main scene. And going to 2D view. I'll have to go to the tutorial apparently. Let's see here. Okay. Yeah, so it's kind of a no-go, unfortunately. It looks like they do provide quite a lot of features, including inventory management, sound, scene transitions, dialogues, which is and a camera player with camera, or a player that follows a camera that follows the player. So that's already going to put us well ahead of schedule, so to speak. We're not sure how long the game will take. The developer, we're going to try to develop it in chapters. All right, so let's see if there's a more general walkthrough on getting set up with this Scoria. There's very little documentation here in this repo in the README, but there's probably much more available in their documentation site. Getting started step by step. So we'll grab all the assets. Thinking if I can bookmark this. Oh, interesting. There's two formats there. I'm not sure which one we'll use. All right, creating Scoria project here. All right, so we go to. That's what it basically did, but let's double check. All right, so asset lib and type is Scoria. Godot doesn't quite scale very well. Okay, looks like the documentation is updated for the alpha. There have been quite a few iterations on this. A little bit out of sync. All right, see if there's an Square UI. Square UI. Interesting. Window mode. 2D shrink 1. All right. Got a characters folder there. Hey chat, how you doing? Have any of you worked with the Godot framework before? Or any other 2D or 3D game engines? We're making a two-dimensional point-and-click adventure educational game. I'm just getting a feel for whether the Escoria framework is going to be a good fit for the project, or if we might do things a little bit more from scratch. Escoria might save us some time. All right, so we're going to create a new scene in here. Call it character for now. Or Graham. Give it the root node of ESC player. Escoria player, okay. I don't know how I'll be able to read documentation and the game engine at the same time with Godot kind of scrunching up like this. Maybe we could, Godot 4 will have that fixed. When we get to making our game more interactive later, using the built-in ESC scripting language, we'll need a way to identify the character and the various items. Escoria uses global IDs for this. Set the global ID for the character using the parameter global ID. One thing, I don't want to lose sight of the chat, but I can put the docs over here, and as well as the chat. Then Godot can take full screen. That's not too bad, you just can't see the documentation, but that's all right. So global ID will be Graham. And add a walk cycle. When a character is moved across the screen, usually an animation player is played to mimic the character walking. This is called a walk cycle. Escoria can play different animations based on where the character is moving to. For example, Escoria will play an upward-facing walk cycle if the character moves from bottom to top of the screen, and a right-facing walk cycle if the character walks from left to right hand side. As Escoria can show mirrored animations, if your character looks the same on their right and left halves, you will not need animations showing them facing both left and right. Escoria can mirror any sideways facing animations, for example, the walking right, walking up and right, walking down and right, to make the other sides equivalent, the opposite sides equivalent. Start by copying the sprite sheet image into the character folder. Hint: sprite sheets combine multiple images of a sprite into one big image and are a very efficient way of using images in the game engine. All right, so I think I can open a little file browser over here. Go to my games. Godot Escoria test, and I think they called it. So start by copying the sprite sheet image into character. Sprite sheet walk, I guess, into the character folder. All right. Add new animations with the appropriate animation frames using the images from the sprite sheet. So how do we do this? They've got then add a new animated sprite node to the ESC player node. All right, so we'll add a child node ESC for Escoria ESC player animation. Oh yeah, actually animated sprite. So good, they're not actually duplicating the wheel there. Add new animations. Okay, so how do we add new animations? Well, we see there's gotta be a way to. Frames. New sprite frames. Hmm. All right, that did it. Okay, so now animation frames. We'll have back. Okay. Actually, they're just saying walk back. Copy these so I don't make a mistake here. Okay, so we'll have to, for our game characters, we'll have to make similar animations. Sprite sheet. We can do that. All right, let me check the chat, make sure. No miss. Hey, what's up, Imperium? Welcome, welcome. How are you doing this evening? Doing some Godot game engine today. All the animations for the character walk, idle, and talk live inside one animated sprite sheet node for that character. All right, so the character has its own animated sprite sheet. Everything is going to be in here. Refer to the animated sprite sheet tutorial in the Godot docs to learn how to do this if you need some help. I'm going to have to check that one out. I think we'll need the idle animation as well. So I'll come back over here, grab my sprite sheet, drag and drop sprite sheet idle into Graham's character folder. Yo, 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 Imperium, where are you at? All right, so then I'm gonna kind of guess, but oh, actually, if we add some more, this is just 1.5. All right, so like idle back would be, oh, whoa, wait a minute. Oh, okay. Let's see. All right, so let's say idle back. Well, that's going to be under the texture from our file. Idle back. Idle right. Ah. Oh, okay. Idle back right. Somehow I've got to. Huh. Wonder how I mirror that. Copy. Well, idle front. Idle front right. That's correct. Idle right. Somehow, gotta figure out how to mirror these. There should be like a little setting here. Walk back. Walk back right. Walk front. Walk front right. Left, but I think either Scoria is going to mirror those or I'm going to have to figure that out. Walk right, so walk left. All right, we got everything set up there. Flip. Can I flip these? H flip out. H flip, horizontal flip. That'll probably happen later. Telling Scoria about the walk cycle. Now that the basic animations exist, we need to tell Scoria when to play which animation. To achieve this, create a new ESC animation resource in the ESC player node's animations parameter. Hop over to the ESC player node, look for the animations parameter. There's just a ton of parameters. I'm kind of just reading through these in awe. Click the new resource and then reveal the relevant settings. The score does not limit the developer in how many walk cycle directions a character can have. It can be 4, left, right, front, back, 8 with diagonal directions, or even more. To achieve this degree of freedom, Scoria needs to know which directions are available. It does that by defining angle ranges within the 360 degree circle. The angle 0 would show the character facing away from the camera, 90 facing to the right, and so forth. The walk cycles only show very specific angles for the character. For example, a 4-direction character, there are only animations for angles 0, 90, 180, and 270 degrees. When the player moves the character in a direction that isn't one of these angles, however, Scoria needs to work out which animation the player would like to use. To do this, when defining a character animation, the developer provides the angle range that will match the animation direction. In this program, the green area shows the developer has chosen a movement of 40-degree angle starting from 340 degrees. In effect, from 340 degrees to 20 degrees will correspond to the up angle. So here's a picture. Our character will support walking in 8 directions. So we'll set up their angles parameter like this. Click on that, set size to 8. For each slot, add an ESC direction angle resource. All right, hopping over there. Their angles, size 8. Very cool. This is really complicated stuff that I'm glad to have a framework to take care of. Click on each resource and set its angle, start, and size settings based on the 8-direction character table below. This will define 40-degree ranges for the upper, left, right, and back animations, as well as 50-degree ranges for the diagonal directions. This setup will result in a very smooth animation. Warning: make sure you always define the complete 360-degree circle when defining a character's direction angles. So we're going to set up the 8-direction character. Entry 1. Oh my goodness, what the heck? Whoa, 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 whoa. Okay, ESC direction angle. Oh, that's huge. They could have told the input what type to expect, maybe. Click on each resource and set its angle, start, and size settings based on that 8-direction character table below. Okay. Entry 1. It's going to be the up direction. Start angle 340. Good thing I don't have to do this arithmetic. Angle size 40. Oh wait, Kesty, don't do that. Okay, how do I gracefully? $20.50. $70.40. $110.50. $160.40. $250. Oops. $250.40. And $290.50. Now that we've defined where we want to score to play character animations, we just need to connect the individual animations with the direction angles. The additional parameters of the ESC animation resource define the specific animation of the character for each direction angle. Directions for the walk angle, idle animations, and speak for speaking animations. Okay. Wait, guys, no, man. That's resource. And the speak animations are optional and only required if your game needs them. For each direction angle, put the name of the matching animation. The name specified in adding walk cycle above. All right. We got to use our previous walk cycle animations. These are the first three settings for direction parameter. Whoa. ECA animation resource. So this is one thing it omitted. We added this page on GitHub. Basically, this tutorial said to set up these arrays, and it was just a complete guess, but based on the name, ECA, good grief, so many of them. And actually typing here would type hinting or whatever. If this input only allowed the correct type, there would be no question, but that's not the case. So I said ESC animation name, because the tutorial's saying to For each direction, put the name. Well, those are backticks. Those are used for code, and putting dots inside of backticks or in code, in other words, it means something different than Grammarly thinks. So I'll just put a request here real quick. It's a small change, but I think it would be helpful. Let's see what they think of it. Let's see if I do anything with CLI bot or anything. Linting. I'm gonna wrap up here in a minute. Just check Twitch real quick. Usually there's more chat going on. Okay, Imperium stopped by. Very cool. Yeah, I guess it's just a quiet night. That's all right. Still running the checks. All checks have failed. Oops, no, let's see the failing check. All right. I'll fix that. 220. 1 and 2. All right. Let's fix that. These are the lines that I edited. Line too long. Oh, nice. Very cool. Very cool. It puts it in the line. That's helpful. Yeah, so they're pretty strict here. Let's see what jumps out. 220 hits further down. Well, there's a long line. So trailing white space, and that made that line too long. Oh, cool. Oh yeah. I don't know what their wrap is, how it's configured. Let's see. Trailing white space. Oh. Hopefully that'll pass muster. Lint. Patch 1. I've fixed them, I think. I fixed it. Very cool. I wonder what, yeah, the documentation is using, let's see, yeah, square docs. What requirements? Restructured text, but Sphinx. All right. Think about using Sphinx. It's a bit complicated, but for our open source project, we might use it. Okay, so I'm going to see if I can get a little bit further along. But basically, what we're going to do is go back through these, the list, and being the names have to correspond with the table. This is a bit of a messy tutorial. Instead of saying walk up, they said walk back. Well, let's just do it. I think I'm going to try it out. See where we get. Up, up, right, down, down. Let's need to open this in 2 tabs. Upright. Ah. In a way, this would be easier in a script file, but okay. I could just define like a list of these animation names, and I could cross-reference them, or a dictionary with the animation name and the whatever the animation the other node is here. These put them in side by side, then they're right there in the same space. All right, so we got this one. Walk right. Now, if I recall correctly, if we open up the animation tab for the sprite, is correct. Walk back right is correct. Let me just get all these in there and then do that as the 3rd step. Walk front. Nope. This next one should be right. Walk right. Walk front right. We're doing 360 degree basically, as far as I understand. Walk front. Walk front left. rock, right, mirror. Hope that's good. Telling its story about the walk cycle. So actually, yeah, that's what we just finished. Now we've defined here what we want score to play the character animations. We just need to connect the individual animations with direction angles. The additional parameters of the ESC animations resource define specific animations. Oh, wait. I just did that. The slot needs to contain an ESC animation name resource. Oh, shnikes. Oh, they did have that in the docs in the next paragraph. Oh, well. All right, so let's do this for idols. Yes, animation resource. Yes, animation name. Yes, animation name. All right. Idle back. I might be getting these out of order, but let's see. I'm not sure if it's going to 360 degree. Defining the character base position. All right, now creating a room. She said a new folder. ESC and ESC room. It requires a global ID. Pub. Winner plays grams. Now we need a background. Pub background. All right. Navigation. Polygon. New nav poly. Say weird. I wonder if it's gonna go in front of that. We'll figure that out later. This course supports having multiple walkable areas represented by multiple navigation polygon instances. These can be switched by a command in the game. This is useful for things like blocked passages. Hey, what's up, Andre Ray? Welcome to the stream. Yeah, we're making an adventure-style game. It's kind of like a quest. Right now, I'm just going through a tutorial learning about the Godot game engine and the Escoria adventure game framework. And our game is open source. It's in the idea stage right now, in the alpha stage. Well, it's going to be an educational game and geared towards kids, so we probably won't be hanging out in a pub. But the idea is that kids will have an adventure. They'll have some relatable characters, and in a town or some kind of it's sort of a life simulation game in a way. They'll play these characters and they'll encounter problems that they'll need to solve using basic knowledge about science and math, physics and astronomy, stuff like that. We're working on many fronts right now. We have to do both technical and art and story, technical, art, story. What else you got? So a bunch of stuff coming together. And it's open source again, so any contributions are welcome if you've got ideas. It'll be easier once the project takes shape to come up with more ideas. All right. Rooms in adventure games sometimes don't have one fixed global light, but instead feature things like lampshades and darker areas. This can be achieved in Escoria by setting up a light map in the ESC terrain node. The light map is a simple texture in which colors are mapped to the character colors as it walks around the room. Scale mapping. If the background of the room is a three-dimensional image, and the upper part of the image appears to be further away, scale mapping is used to create a three-dimensional effect when the character moves from the top to the bottom. See, this is why we want to use a framework like Escoria, because it's going to handle some really tricky details for us. Scale mapping is used to create basically, it's achieved in Escoria by using a grayscale texture. The darker part of the texture is considered to be the further away from the viewer, and the lighter is considered to be more in front of the viewer. To fine-tune the scaling of the character, set the scale min and max parameters in the ESC terrain. All right, so we got scaling, and we're loading the scale there. We got a light map. Multiplayer. Wow, this is cool. Do you have any game development experience, Andre? Are you interested in learning, or what's your kind of open source background? Let's see. Camera limits. As was mentioned before, the background can be much bigger than the screen size. We can see that this is the screen size here, and the background is going pretty far over here. So how we're using the camera limits, we can tell Escoria that it can pan over the complete background using the game camera. Set the ESC room node, select it, and set the first entry for the camera limits, parameter 0, 0, such and such. I'll copy these in just a moment. So we're going to the camera limits. Here we are. 0, 0, 39, 70. The picture is different than the text. I'll go with the text because the text is usually easier to update than the picture. Setting a starting location. We have to tell Escoria where our character should start a new scene. For pointing out specific locations, we can use ESC location node type. Add one and rename it to start. So this looks like it's in the ESC terrain. Child will be ESC location. We'll add that there and name it start, so it's clear with this. And heck, I can rename this like floor and background and stuff like that. But let's leave it as it is for now. I don't want to break things. Yeah, it takes a lot of time to do these types of stuff. What's taking up much of your time? Do you have studies or work? What's keeping you from taking the first step in Godot. I bet you could find a little bit of time if you have a particular challenge, for example, something you're interested in doing with it. And on that note, what would you like to learn Godot for? Is there a game idea you've got, or just general interest in games? Let's see. It's generally recommended to give nodes a meaningful name, especially with bigger complex rooms. It proves to be very helpful. In its parameters, the start, set the global ID to start, and select his start location. It's about time for setup. Now let's try a game for the first time. Whew. All right, I hope things will work. We'd like to test out what we've done so far, but first we need to tell Escoria what to do when a new game starts. Our first ESC script. This is done using ESC, integrated Escoria scripting language. Oh boy, here it goes. I would rather learn just GD script. While you could use GD script or other language supported by Godot directly, we added ESC as a specific language for adventure games. So very typical game commands like making a character speak, letting them walk across the room, etc. are very easy to use. All right, I'll give it a try. I'm going with it. The game startup itself is also coordinated using ESC script. Okay, scripts are plain text files with an ESC extension. Create in any text editor you choose to use. Create a new ESC script which will be our main game script and call it game.esc. Okay, where do I create this? I suppose it'll be right here. That's a problem right there. Game.esc. So that won't work. Well, how did it?